This is from a presentation about commercial real estate. The truth is it really could be for any industry, but you're going to see a lot of real estate stuff in here. I went skiing this past weekend. This is what I wear when I ski. There was an 80s day at one point, and I just kind of got stuck, right? Everyone was like, "Hey, I love your onesie," and I loved the positive feedback, so I wear that kind of stuff all the time now. And I'm a big skier, so I have a ski metaphor for you. And it has to do with aerials. You know, those ski tricks, flips, that kind of stuff that they do. So if you ask someone who's standing there just on the ground, right, flat, to do a trick, they can't do it, right? Even if they're the best ski jumper in the world, it's impossible to do from a flat dead start, right? We need something, and you might think of it as a jump. Technically, it's called a kicker, right? So if you put someone in front of a kicker and you ask them to do a jump, what are they going to say? Need some speed. We need the in-run, also known as the incline or the mountain. But I would never do this jump because when you hit that flat ground, it's going to be like running into a brick wall, right? So you can't ask somebody to kill themselves that way. You need something else. It's a landing, right? And of course, at the end of the landing, you got to stop and look at your score and get your flowers and hold up your ski. So we need a finish, right? And if we have these things, then we can do something interesting. But putting this stuff in place is not easy. It's complicated. If you get it wrong, you're in trouble, right? Like you can imagine someone, you see those videos sometimes of someone jumping on their bike and they go way too far, they didn't get the velocity right. So you want to do it the right way, right? There's the right angles, the right vectors, the right distances. And if you do, then you can do some really interesting stuff, right? And we think of that as tricks. Make sense? Okay. We're not here to talk about tricks. We're here to talk about artificial intelligence. And of course, there's a parallel here. If we want to use an AI model to do something, we need to do some things first. You can't just be like, use AI, go for it. It doesn't make sense. So what we need is we need to have data. We need to give that data to the model. Okay. Once the model does its work, we need to get the results and we need to use them, right? And this is like, if we can do these things, then we can do trick after trick after trick, okay? So it kind of looks like this. And we have data in the company, right? There's a bunch of different disparate data sources in most organizations. And we know we're going to need to get it up there. We know we're going to need to get it back. And at the end of the day, we're going to have people doing things, or we're going to have another program do something, or we're going to change data, right? So this is kind of the world we're in, and it's like some of the stuff is a little hazy. How do we get that data all combined together? How do we send and receive it to a model? And how do we make it useful, right? So these are the challenges that we have. But by far the biggest challenge has been the AI models, right? Which historically have been extremely complicated. And so I think of this a little bit like if we were talking about going to Mars, we would need a rocket, right? If I'm sitting here planning, like, here's my suit for Mars, and you'd be like, where's your rocket? How are you going to get there, right? It doesn't make sense to focus on certain things until, the hardest thing is done. Then that opens up new possibilities. Well, it turns out like a massively, wildly amazing thing happened in the last couple of years, which is that extremely, extremely complicated stuff that was like beyond our reach became extremely, extremely easy. Like shocking thunderclap type stuff is Google, IBM, AWS, Microsoft. They've all just rolled out these models that are super complicated, but super powerful, right? And by the way, they're not even as complicated as they used to be now because there's tools and stuff that you can do. But think about it this way: is the thing that used to seem insurmountable is now as easy as it could possibly be. It's like teleportation, right? So now you can pick from any of these things, and it's time for us to solve some of the other challenges, right? So, for example, how do we get information to those models and back? Well, we built at Stemmons the central AI connector, okay? And what it does is it keeps track of those models, and it pushes information up and it pulls information back, and we've now solved that issue, okay? And we're working on new connectors as like little nodes to connect to different models and different AI services, but think of that as being a part of our system that you can now get information up there and get it back, right? And then we get to things like, combining data. Everybody in the room knows how Stemmons works, so we know that we can use that as a place to bring together disparate sources of data into a normalized data set, right? You can multimodal, transactional stuff, metadata, it's all available, right? And then how do we make the results useful? Well, as it turns out, Stemmons has this thing called cases, right? Where you ask somebody to do something, entities, which are things, right? We know how to trigger API calls, and we know how to change data, okay? And so this is basically the world that we're in, is if we can do all of these things, then we have a system. And it turns out with Stemmons, we're kind of covering all of this area, right? So what we need outside of Stemmons is we need your data, okay? We can work with other AI systems, not just stuff that we've developed ourselves or that you've developed yourselves, but total third-party stuff. And we can even work with your other systems, right? So if you're using something else for CRM or you're using something else for whatever, we can interact with those things too, right? And all of that stuff in the middle, we're covering. Okay, so let me show you how some of this stuff works. Okay, the first example is news delivery, right? So think about this. We have a portfolio of customers, tons and tons of different customers. We know all about these businesses, and we have people that are responsible for them, right? So let's say we've got a property with a bunch of tenants, and we've got a property manager, right? In the meantime, all this news is kind of like flying by, right? Every day, there's hundreds of sources of data that are displaying news about our customers. And in an ideal world, I would tell the property manager, hey, look at that customer, check the news, get it and read it, and do it for all of the customers in your property. And then I would expect every other person to do that as well, right? Also, maybe we've got a really important customer and I want 5 different people to watch that customer because they're important, right? It's just never going to work. So the question is, how do we fill in that middle? And we start with data. We know about our customers. We know about our people, right? And we have this thing called Watson. You guys are familiar with Watson? It's IBM's, artificial intelligence brand. And they have a thing called news discovery. So we set up some rules. We said, look, I want, for every property, I want to look at all the customers in that property, and I want to get all the news about them, and I want to send it to the property manager, right? And I want to do this on a schedule, right? So I've got 3 properties. It's going to pick who are the customers at the time in that property, right? Who's the property manager, and it's going to send the news to that person, okay? At the same time, we might have other stuff like, hey, I've got a regional VP for each region. They want to see only the biggest customers, right? They don't need to see every tiny customer, but the big ones they care about. Okay, and similarly, we've got a chief risk officer, and they want to see news about bankruptcies, because we got to jump in when there's, right, so on and so forth. So this is how it works. We have these rules. The rules create instructions. It goes up to the model, right, through our connector, and it comes back down with results, and we turn those results into cases. Okay, and the people get to see those cases, and so the news kind of flows to them. And if some of the news isn't accurate, they can kind of mark it, and we have a feedback loop so we can train the model, right? Now, you could do this by going and setting up Google Alerts, right? Everyone knows how that stuff works. Just imagine the likelihood of everybody going and doing that. And then you say, oh, I need you to move to that other property. There's 50 new tenants in that property. cancel all your old Google alerts and go do new ones. And also, by the way, we just bought a property. So let's go add all of those, and that tenant left, but we have 3 new ones. It's never going to happen. This just does this automatically, okay? So here's how this works. We keep track of kind of the providers and the models that we build. We have rules. The rules have kind of some instructions in them. I'm kind of skipping the technical aspects of this. You know, we have a scheduler. It's called Cast. We use Cast to schedule all kinds of things. It's now scheduling news. We get instructions and results, and what you end up with at the end of the day is something that looks like this, okay? And you're the property manager. You get a case. It says, here's your news about your tenants, right? And it's like, great, thank you. You know, you can imagine a new person coming into the company and like their first day, they're like, oh, here's here's all the information, right? It's like, this happened. Congratulations, you guys, I saw you won an award. You know, you could stand in the lobby almost and just, kind of congratulate people on things. Speaking of standing in the lobby, I'm gonna. Oh, and by the way, this is live now, so this is not theoretical. We're doing this. Next thing is another lobby story. You guys have all been upstairs, right? This is the lobby, and I'm a coffee drinker. Okay, it drove me nuts. We have a coffee machine here. We have a receptionist here, and I would very often be saying, "Can you have somebody make some coffee?" Right? Like, is there a way to not be the one who's dealing with the coffee all the time? So it would drive me nuts that I was the one who was saying, can we have some coffee, please? So I came up with a very sophisticated technical diagram of how I wanted this to work. And it's like, I want to have a camera pointing at the coffee pots. Okay, this is upstairs. You guys can go see this right now. The camera takes a picture every minute, right? And if the system figures out that we need coffee, it sends a case to the receptionist. Okay, so how do we do that? Well, let's look at the schematic. Okay, we have data. We have pictures of coffee, or the coffee pots. Okay, we have who's the receptionist. Okay, and we also have classified pictures of coffee. And this is not like the secret one. This just means here's a picture, and we have determined whether this represents needs coffee or does not need coffee. Okay, this is what we call the training data, because the model we're using knows nothing about coffee. We never use the word coffee. We just say, here's a bunch of pictures, and these ones represent a certain state, and those ones don't, right? So, so what happens is we used AWS, their recognition. That's not a typo. That's the way they spell it. And the result at the end of the day is that we want a case that says, please make coffee. Okay, and so what does it look like? Well, here's the data. Okay, it's a bunch of images. There's a new one every minute, right? You can literally see the increments of minutes in there. So the camera takes a picture, dumps it into a file. That's our data. And then we needed a way to kind of classify it. So we built a little thing where you would see random images and you would just click if it represents needs coffee, doesn't need coffee, or we're not sure, right? Can anyone guess, anyone who wasn't involved in this project, how many pictures we had to classify before the system was smart enough to make a prediction? Yeah, you guys are bracketing. It was 100. Yeah. So 10 is not enough. 1,000 is too much. After 100 pictures, the system was smart enough to know if we needed coffee or not. Okay? And here's what it looks like. It's like, hey, here's a case. Now, you guys are familiar with the case system, right? Because we could all create cases in Stemmons. But this case is not created by a person. It's created by artificial intelligence, right? And what it has is a picture of the coffee, and it's like, hey, please make some coffee, okay? And by the way, sometimes there's a mistake. So this one, there was a person in the picture, and you can see there's an opportunity to say, is this picture accurate? And they've said no here. That goes back and trains the system to make it smarter, okay? Now, I know that coffee is not a really important use case, but the ability to deal with image recognition is. In other words, if you're in a snowy place, do we need to shovel the walk because someone's going to trip? Is there, are we overparked? You know, how many people are waiting in line? You know, is this room clean? You know, we have a client who wanted to know how much food is being wasted after events. So they wanted to take pictures of the buffet table because they couldn't give the food away and they were paying for it and they had no other way to do it. Another customer is looking at the recycling bins to see what's in them, to classify whether, you know, they're in the recycling business, so that's different, you know, for them. But anyway, the point is, there's a lot of different things we could use this for. The important thing is being able to use it at all in the first place, right? Okay, so, you know, next thing, default prediction, okay? Are our customers going to make it? And don't we want to know, right? So look at the data model there. So we've got a bunch of stuff from our accounting system, okay? You know, I would think of this, there's metadata in accounting, there's transactional data in accounting. There's also things like, have they been having a lot of work orders? Or has the number of work orders been changing? What's their customer satisfaction score? We took all this stuff, we packaged it up into a data set, and we sent it up to AWS with their machine learning batch prediction system. And eventually it told us, I'm confident to make a prediction, and you know, here it is. So we can use that to create a case, like go talk to this customer. How's it going? You know, is there anything you need? You know, we may use it to plan our inventory. If we're about to go build a whole bunch of spec space, but we have a bunch of customers who we think might end up leaving, maybe we're going to hold off on building new space because we're going to get some back. You know, or maybe we need to start stockpiling cash instead of distributing it, right? Or maybe we're about to refinance something and we need to rethink that because we don't want, you know, customer departures to change our deal at the last second. So there's a lot of things we could use this for. We could also use this for tenant expansion, by the way. Who's likely to need more space, right? Who's likely to lease space? Which site that we're about to purchase is likely to be successful? Which property is a good deal for us, right? Which tax challenge is likely to succeed, you know? Or which argument is likely to succeed for a given thing? I mean, like, there's a lot of things we can start doing with this. You know, we might, and then, oh, by the way, we update the records. I'll show you that in a second. And of course, we need training data, like, you know, who defaulted and why, right? If we can't tell the system who defaulted, then it's never going to learn about defaults. So here's what this looks like. This is a customer profile. This is an entity, right? So it's a customer entity. And information is coming from a lot of different places in here. But one of the lines is the risk data that comes from artificial intelligence. It's just been slotted right into the normal flow of information about our customers, okay? Now, the developers here didn't, you know, they were being developers and not, you know, business people, so they left all the decimals in. But basically, you know, we've got information coming from artificial intelligence into our customer records. Stop for a second, like, that's really cool, right? There's lots of different ways you could do it, but the fact that we're doing it, it's like we built a jump and we just did a trick, you know, and these tricks can be valuable. You know, we also can kind of roll it up. Here's a report. Likelihood of default per property, right? Now, there's many, you know, different things we can do. This is one we haven't done yet, but we're looking at. Okay, so the first three I showed you are live, real things in our system that we're using at Boxer. This is stuff that we're working on. So if you think about people who are coming into the company, okay, we've got applicants, right? They have applications, they have resumes, and we do a job fit test. So this is kind of one of these, you know, answer a bunch of questions, and it gives you a little report that says whether you're likely to be successful in a given job or not, which may or may not be accurate because in the past it's been disconnected from our actual performance results. And that's what we're trying to solve for. So we have all that stuff for applicants, but we also have it for people who are employees, and in addition, we have their performance reviews. right? So the question is, can we predict the performance score using the pre-employment information? Okay. Now, why is this particularly interesting? Because we have now created systems in our company where we don't need the same level of experience that we used to need, right? The experience is built in many ways to the system, okay? So we used to look at resumes and we would look at keywords and we would say, how many years has this person been working? Have they done this? Have they, like, we literally would put the keywords at the top of the resumes to, you know, and basically what we're doing is we're participating essentially in an auction to rent somebody's experience as represented by the keywords on their resume, right? That's our employment approach. And every other person who needs some experience in the company is bidding against you. So whoever pays the most gets to use that experience for the time that the person works there. Now, I hope that doesn't sound too clinical, but that's, you know, kind of what's happening, right? To the extent that we can get off of that track, we can find people who are really excited about their jobs, where it's new opportunities, where they're going to bring new approaches, and also, frankly, where they're not bored of doing the same thing, right? They'll be more open to innovation. And we can build into Stemmons these things that help them kind of remember to do things or give them instructions and that kind of stuff. But what are we looking at when we hire them, right? So what we're now getting into is taking these different data sources, putting them into formats that we can use. And that includes, for these job fit tests, we're getting the raw questions that we've been asking people back as long as we've been using this tool. So the raw questions and the raw answers. And what we do is we take that information, okay, we have that data set, we have the job fit stuff, and we have our training data, which is how well people did. And we can use that to back into, here's an applicant, right? And how well are they going to do? We send that up to a prediction model, and we could say, hey, we should really look at this person for this job. You know, they would be an awesome leasing agent. They would be an awesome project manager. They would really, property management is for them. I mean, it could be anything. We could also give them a score and just say, hey, this is the likelihood that we think this person is going to be successful in this job based on all the prior people that we interviewed that had a similar profile and the results that we saw from those people, okay? So that's kind of part one. Part two is a little more interesting, in my opinion, is as people have been at the company for a while, we have a lot of information about how they're doing and their activities, and in particular, we have activity logs that come from the cases. We also know when somebody leaves, right? So a former employee, we would look at somebody who left and say, were we sad when they left? Okay, we think of that as a regrettable loss. You know, oh, I wish I knew that person was not happy with what they were doing. We were about to promote them. You know, we could have offered them another position in the company, right? We should have included them in the leadership meetings. You know, maybe I gave them too much to do, or I was taking them for granted, right? But we don't know until it's too late. Sometimes people leave and we're happy. You know, we're like, phew. Sometimes people get let go, right? And other times we're not sure. But think about the people when we're sad that they go, because we have invested in them. They know their way around the company. They know, but very often we just let people kind of do the same thing and they get bored. You know, and they want other challenges, but the company wants them to stay where they are because they're productive, right? Because they're good now at doing that job. So what we're looking at is, okay, you know, can we predict the exit mode? And the activity log is a big part of it. So if you remember, some of you have seen this before, other ones haven't. Here's Manhattan and Boston, right? Now looking at these maps, which one of these is easier to navigate? Manhattan. Yeah. I mean, you can see, it's like, it's got a grid. You know, you don't even have to speak English. You don't have to have a map. Boston is kind of a nightmare. So here's a graphic. I didn't invent this. I grab these from the internet. I should remember the name of the guy who came up with this. It was not me. But it shows the orientation and the length of the streets. Okay? So, you know, there's Manhattan and there's Boston, and it kind of reflects the map, right? Now let me ask you guys another question. What's easier to navigate? Sabak or Smedrevo? Sabak, yeah. Like, you could look at this in a second and understand that one of these cities is far easier to navigate than the other, right? Now, I don't know the size of the population. I don't know if they're in the mountains or in the desert. I don't know what country they're in even. I should probably learn. But by just looking at this shape, I can tell you which one I will have an easier time navigating, right? So hold that thought for a second, right? And let's think about what we understand about people. So we have cases. I've shown you a few cases, right? You guys are, you know, you've seen the dashboard stuff. In Boxer, we have over 3 million cases, right? And each case has an activity log. So we have the visual version and we have the computer version, right? So every time someone's doing something in a case, we're keeping track of it. That gives us 51 million data points of times that somebody interacts with a system, right? Now, let's think about the life of a case, right? Because we can engineer some measures. This is, you know, somewhat of an old school way of approaching it, is engineering measures instead of having the measures or the features kind of discovered by the system. But, you know, we can look at a case and say, hey, here's all these things. There's certain roles that people adopt for a given case. I created it, I closed it, it's assigned to me, and things that happen. And we can make a timeline, and we can start measuring times between these things. So how long was it open? How long was it before someone looked at it? How long was it when someone looked at it and then closed it, right? And we can also start doing ratios. What's the ratio of time for this particular case, right? In fact, we're able to come up with 400 measures for every case. There's 400 different things that we're looking at. Was it closed without someone looking at it? Was it closed by the same person that opened it? What was the ratio of time that it took between the time they first got it and the time they looked at it to the time that they closed it, et cetera, right? And so if you think about the math here, we've got 3 million cases. There's 400 measures for each case. We have 1.2 billion data points in our small real estate company. 1.2 billion pieces of information. Now, what I can't do is tell you which ones are important, right? Like, I just don't have the capability of understanding that. But what I can do is I can tell you, here's all the information, right? And here's the outcomes that we have, right? For example, it might be which projects went off track, you know, or it might be, you know, which person left and we were sad about it. So here's what we have: is we have this same model again. We've got the activity logs, right? The engineered measures and the raw data. Okay, we've got the outcomes, what happened when people left. And what we want to get to is, hey, here's a case, you know. I want to go check in on somebody. Maybe they've started kind of coming in a little later, or, you know, closing things without really looking at them, or they're, you know, the nature of the notes, they used to write long notes and now they're writing none, you know. I don't even know what it is, but I know that the system will be telling me, this is someone that you should probably go talk to, okay? It might be that we want to offer them another position. You know, hey, you kind of conquered this dragon, like, let's go to the next level, right? It could be that we've done a bad job of arranging their work, you know. We put too much on their plate. We didn't even notice it. We just kept giving them more because they were good and, you know, they weren't complaining, right? But now they're complaining by looking for a job somewhere else, right? So this is the kind of world that we want to be in, where we can do those things. So this is the basic framework. There's a lot of different capabilities that exist in these AI systems, okay? If you haven't done it already, go like check out any AWS, you know, Watson, whatever, and just see what they have to offer. It's amazing. we also have areas of interest for us, right? So we've got operations, we've got our assets, we've got customers, and we've got our people. All of these things are valid areas of inquiry for these kinds of interventions. And then we have the stuff that we would do with it, right? We've got, do we want to create a case? Do we want to create an entity? So on and so forth. Activate some other program or change data. And when we think about like what should we be doing right now, if we take a step back and look at the overall like kind of global direction that businesses are going, in my opinion, what we need to be doing right now is building the infrastructure, right? And kind of getting it ready, right? So even if the very first jump is just a tiny one, let's set it up so that we can do these things in our companies in a way that really adds value. Because once we start, if you can do one or two of these things, you can end up really doing a lot. All right. And the idea being that we can combine these kinds of approaches. Sometimes it's a person, sometimes it's AI. The AI will help the people focus, kind of identify opportunities, and we can string these things together in a way that is really interesting for our businesses. Now, I love the way this thing ends. It's probably not thematically accurate, but it's kind of funny. I mean, how's he going to get down? Right? And by the way, if he missed that landing, that would have really been painful. So bad metaphorically, but kind of fun. So this is kind of the world that we're in right now, and with Stemmons, and especially with the central AI connector, we're really able to do some of these things immediately.